What is a rational number?
Number.
Be more specific. Well, thank you, Devin.
It's not a fraction or a decimal?
It can be, yeah. Jake.
A number that isn't a negative.
Uh-oh. I think we gotta refresh our memory what rational numbers are. They are rational numbers. Rational number is any number that can be written as a fraction, where numerator and denominator are integers. So that's your official definition. That includes a lot of numbers. Lots and lots and lots of numbers. So this includes all your natural numbers, your whole numbers, your integers, and any decimal that ends or repeats. Any decimal that, we have a fancy way of saying ends though. Anybody know what it is? What'd you say? Starts with a T.
Maybe you guys know this. If you get fired from a job, if your job ends.
Yes, terminates. Terminates. So again, that's just a fancy way of saying ends. Huh? Oh, thank you. Any decimal that terminates or repeats. Okay, so pretty much the only numbers that don't fit into this are the irrational numbers. Those are the numbers that never and never repeat. Okay, so we talked about those in the last chapter a little bit. Pi, the weird square roots, so like a square root of 7.
2.
Well, I was giving examples of irrational numbers. 2 would certainly be rational because it fits into one of these, fits into all three of these categories actually. So, yes, Cohen. It's 1.41 blah 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 blah.
So it's irrational.
Correct. Oh, you were saying square root of 2. I thought you just meant the number 2.
No, the square root.
Oh, okay, yeah. I was confused there. So, yes. So, let's show some examples of some rational numbers. So, example of rational numbers. Plain old 2 is a rational number. Is 0?
Yeah.
Yeah, because it fits into one of these, so it's also a rational number. How about negative numbers? Are they in here?
No. Yes.
Yeah, because they're part of integers. So something like negative 17. How about, I said any decimal that terminates or repeats, but what about fractions? Yes, look back at the original definition. Any number that can be written as a fraction. So if I had something like 2/3, that's a rational number. Almost everything is a rational number, unless it's one of those weird numbers that never ends, never repeats, like pi or a weird square root. Everything else is rational that we're going to talk about in this class, okay? So I could have a negative fraction. I could have negative, 4/9. Let's also put up some decimals. How about 0.25? That's a decimal.
At put 6.5.
Sure, that's fine. That's a decimal that terminates. It ends. 0.25, that's it. It's done. What about this number? Negative 3.61497. Is that rational? Yeah, because it ends. There might be a lot of the decimals, but it doesn't matter. It ends. What about something like this? What's that bar over the 3 mean?
Repeating.
It means repeating. Are repeating decimals part of the rational family?
Definite decimal.
Read right here. Any decimal that terminates or repeats. Repeating decimals are part of this family. As long as the decimal ends or it repeats, it counts as a rational number. You with me? Okay. All right. There's let's see. Let's say I wanted to compare a few of my rational numbers. Comparing rational numbers. I'm going to let you in on a little secret here, but you already know this. But this is going to make your life so much easier if you pay attention to this first. So when I say comparing rational numbers, that's telling me which one's bigger than the other, which one's greater. Well, sometimes it's really easy, right? Let's do an easy one. Say I want you to compare, I don't know, 6 and 10. Clearly, which one's bigger? Which one's bigger? 10. 10's bigger than 6. Right? Let's make it a little bit more difficult. Let's say I went into negative land. Let's say I want you to compare negative 3 and negative 5. Which one's bigger? Negative 3 is bigger. Sometimes, though, it's not so easy. Sometimes I'll give you something like this. What if I asked you to compare, oh, I don't know, how about 2/3 and 4/7? Huh. How do you know?
Because it's
Closer to zero.
almost, like, it's almost full, and then 4/7 is, like, not as full.
Closer.
I picture, like a circle.
Okay, okay. But what if they're really close?
Are they equal?
So here's something that I do like what she said. Are they both more than half? Let me ask you that. They are both more than half. Sometimes I can do it in my head. If I know that one fraction is less than half and one fraction is more than half, then obviously that one would be bigger. Okay? So we need some more mathematical ways, though, to determine. You have a couple of options. One option, you do? Well, one thing you can do is you can turn them both into decimals if you wanted. I would not recommend that here. There's an easier way. Because I don't know. I know what 2/3 is as a decimal. I don't know what 4/7 is as a decimal. Do you? If you know it, great. If you don't, I don't know it. So I could either do the long division, and I could get it as decimals. Or, you ready for this fancy math?
No.
Yes.
I'm ready.
5, 4, 5, 7.
You can turn them into decimals if you want, but there's an easier way. You can multiply the diagonals. So, if I multiply, watch how this works. I'm actually going to switch colors. If I multiply my diagonals, 7 times 2, I said I was going to switch colors. I thought I picked red, but it's actually green. Yeah, see, I swapped these two. I didn't mean to do that. Okay, I wanted the red one. If you multiply the diagonals, 7 times 2 is 14, and 3 times 4 is 12. So, since 14 is bigger, 2/3 will be bigger than 4/7. Isn't that neat? So that's a lot easier than changing it into decimal, in my opinion. Do you agree?
Wow, that's cool.
Yeah, let's try another one.
So, Mrs.
Oh, yeah.
Sadie, I just want, and I see the way you did it, but I just want to say it out loud. You have to multiply going upward. If you multiply down, your number's gonna be on the wrong side. You have to put the number.
Yeah, so start here, multiply, and put the number up top. Multiply and put the number up top. So let's try another one.
Because if you go the other way, you might put the number at the bottom.
Yeah.
And then you get-
Let's try something like, I don't know. How about 8 elevenths and 7 ninths. Try those two. You have an answer already?
You don't need it.
Sure. Thank you. Cohen, you have an answer already?
Do you have a count system?
No, I just use a sticky note. Yeah.
I know it's one.
Cohen, which one do you say is bigger?
7, 9.
He says 7 ninths. Do you all agree?
No.
Yeah.
Well, let's try it. We're going to multiply the diagonals. So if I start at the bottom and multiply up, 11 times 7 gets me
77.
77. 9 times 8 gets me 72. 77 is bigger, so yes, I want 7 ninths is the bigger one. Okay. I mentioned that I was going to tell you some fun little fact, and I never did. So, but you already know it, but sometimes kids forget this. I want you to put a star on your paper and remind yourself that any positive number is larger than any negative number. You don't even have to do any math. If I'm asking you to compare two numbers and one's a negative, it's automatically the small one.
Almost the old one.
So even if it's, it could be anything. It could be, I don't know, negative 19, and I want you to compare that to, 4/7. You don't even have to do any math. If one's a positive number, it has to be the bigger one. So who's bigger? 4/7. It's gotta be. Any positive number. It could be the tiniest positive number in the whole wide world. Let's actually compare some decimals. Say I want you to compare. Yeah.
If you're comparing like a whole number or an integer to a fraction, how would you do that trick that you showed us?
Well, you mean if they're both positive or both negative?
Well, whole
He's talking
number
about a solid or
against the
a
fraction.
Well, here's one thing I would ask you. As long as the fraction is less than 1, which most fractions are, right? Unless it's improper, right? So if you had, let's do it. Say you wanted to compare 4 and, 3/5. Is 3/5 bigger or smaller than 1? Smaller. So you don't even have to do any math. That's smaller than 1, and 4 is certainly bigger than 1, isn't it? Are you with me? Or you could can't you write 4 as a fraction?
Yeah.
How?
4/1.
Perfect. And now you can do the same thing. You can multiply the diagonals if you want. So if you did have a whole number and a fraction, that's one option. Just make them both fractions, and now multiply. 1 times 3 is 3. 5 times 4 is 20, so certainly we still get the 4 being bigger than the 3/5. In my head, I ask myself if the fraction is bigger or smaller than 1. If my whole number is bigger than 1, I know it's got to be the bigger one. But some fractions are misleading because they're improper, right? So let me try and trick you. let's say you had something like this. I don't know. How about 5 and 26 fourths? I don't know. And I asked you to compare these two. Sam, you have an answer? What?
The second one.
This is bigger? Do you guys agree? Yeah. So again, if you want, you can turn 5 into a fraction and then do the same thing. 5 times 4 is 20. 1 times 26 is 26. So yes, 26 fourths is bigger. Sam?
That was a good
You
trick.
could also do 5 multiplied by 4 if it's smaller than the integer.
You could also change this improper fraction to a mixed number.
Well, isn't it, doesn't it just equal 6? Oh, wait, no. Never mind, I did it wrong.
But it's bigger than 6, right? So it's 6 and then another half. So it's definitely got to be bigger than
Yeah,
the 5.
I wrote it down as 24.
Okay. All right. So, oh yeah, I wanted to do one like this. What if you had this? Tiny number. And I asked you to compare it to this number.
Probably bigger.
Exactly. Any positive number. I don't care how tiny the positive number is. It's automatically bigger than any negative number. That's it. Maybe. Maybe.
That was some cool math I just learned.
Right? I like that.
Especially with that cool trick where you learn how to solve fractions.
Mm-hmm. Let's do one like, what happens if I mix them together and I do a decimal and a fraction? So how would you do something like this?
I forget if it's into a fraction or decimal.
Let's do those two. 0.7 and 2/3.
How's that?
Well,
I know it's bigger.
which one?
Fraction.
How? So you have a couple different ways to do this. You can either turn that into a fraction, so then you have both fractions and you can do the multiplying like we were just talking about. Some of you might know this as a decimal. Does anybody know this as a decimal? Maybe we should make a chart of our common fractions. That might be a good idea. Nobody knows that one as a decimal? Tommy, you know it? That's the other way around. That's 3 halves. 3 halves is 1.5. Ben?
This would be 0.666 repeating.
You're correct. Yeah. So, if you happen to know that that's 0.6 repeating, now let's compare those. Which is bigger, 0.7 or 0.6 repeating? 0.7. I don't care that this is 6s that go on forever. Doesn't matter. 0.7 already wins. It's already bigger. 7's bigger than 6. So, that one's bigger. By the way, let's say that you didn't know that as a decimal. Okay? You have 2 options. You can either do the long division to figure out what it is, or you could change this guy into a fraction, which actually isn't that hard if you know how to say that number the right way. I was saying 0.7. That's the lazy way. It's not really 0.7. It's 7/10. The way you say the decimal is the fraction. 7/10. That is.
Or
Yeah.
0.7 over 1.
Oh,
know
I
that-
guess you could do that. Yeah, you
That'd
could.
be a lot of harder math.
Yeah, because then you would have to do 3 times 0.7, and then, I mean, you're right though.
That gives us 0.21. 7 times 3 is 0.21, I believe.
It would be 2.1 though.
Oh, 2.1.
Yeah.
0.21.
So, and that actually brings up a good point. You want to try and avoid having decimals in your fractions if you can. So usually when we write a fraction, we want integers on top and bottom. So 0.7 over 1, 0.7 is not an integer. So you want to avoid that if you can. So 7/10 though, that's pretty easy. You know how to, I hope that people know how to say that, right? You know how to say that correctly? Some of you said it right away, but those of you that didn't say it, do you remember now that that's 7/10? Yeah, you with me? So 7/10, that's exactly the way that you write the fraction. 7/10 and 2/3. And then I can do that same trick. So 3 times 7 is 21. 10 times 2 is 20. 21's bigger. 7/10. Whether we change them both to decimals or both to fractions, it doesn't matter. Let's try one where they're both negative. Whew.
I don't have enough room on my.
You gotta go to another sheet, I guess. Let's try, oh, I don't know. How about, let's do this. 0.45 and, oh, I wanted to make them both negative, didn't I? And negative, oh, I don't know, 3/5. You might be able to do this one in your head. Be careful, they're both negatives. So what I like to do, me personally, I pretend, I'm like, okay, they're both negatives. Let me pretend that they were both positives for a minute. I'd find the bigger one. And then once I go into negative land, it becomes the smaller one, right? Because the further you go into negative land, the smaller the numbers get, not bigger. You have an answer already? Let me make sure I have an answer. Now I'm messing myself up. Hold on. Okay, which one's bigger?
The one that you put the, oh, wait. Bigger is 45.
Yeah, when they're in negative land. Okay, so let's try this. Pretend that they're both positive for a minute. 0.45 and 3/5. Okay, pretend they're both positive. Who's bigger? Yes.
3/5.
How do you know?
Because it'll be 300 and not 225.
It's 60.
You can. Okay, right. So you turn that into 45 over 100? Yes, you definitely can. So you can turn that into a fraction. 0.45 properly says 45 hundredths, so it's 45 over 100. Here's what I thought in my head. Is this bigger or smaller than a half? Smaller. Is this bigger or smaller than a half? It's bigger. So right now, this is the bigger number. But then when I go into negative land, doesn't it switch? So that's my bigger one. That's how I did this problem. Not saying that there's not other right ways to do it. There's plenty of right ways to do it. But when you have, especially with the negatives, because we get so messed up. So I highly recommend, if they're both negative, pretend that they're both positive, get your answer, and then just switch it. If one's positive and one's negative, what are you supposed to do?
Take the positive.
You just automatically take the positive one. There's not even any math to do. And then if they're both positive, you try some of the things that we've already practiced. Okay? One more thing that I want to show you before I give you something to try on your own. What if you have more than two numbers? So say you had 3 or 4, and I asked you to put them in order. Let's try that. So let's do order from least to greatest. My first example, I'll make it easy, and then we'll build from there. So order for me the following numbers: 4, -2, 1, and 0. You have it already?
Yeah.
Good, you all should, because this one's easy. All right, Cohen, go ahead. What's the smallest? -2. Then?
0,
Then?
1.
Then? Okay, of course. All right. Let's step it up a notch. Let's do, No, that's a 1 with a bar on top of it. So that's 2.1 repeating.
Oh, I know.
Take these 4 numbers and order them from least to greatest. Well, I want everybody to try. So in your notes, write what you think it should be. I'm not seeing, I'm seeing about 2/3 of you doing what you're supposed to be. The other 1/3, I'm not quite sure what you're doing. So I want everybody to try it. Write down your answer. Least to greatest. Least to greatest. I'll give you 10 more seconds.
Kind of like a computer.
I never found it.
Thank you. Actually, you can put it in the trash. All right, Cam A, what is the smallest in this list?
2.01.
Correct. 2.01 is my smallest. The next smallest would be
2.1. Repeating. 2.1 repeating.
which is it?
It's 2.1.
It's gonna be 2.1. Think of this as money. Well, here's one thing that might help. If they see how this one only has 1 decimal place, but this has 2, this has 2, this one only has 1. Sometimes it helps. Actually, 2 things might help here. To write them vertically. So I'm just gonna write my list vertically. And if it's 2.1 repeating, doesn't that mean it's 1, 1, and then it just keeps with ones? So what I want to do is what number would go right there? There's a 0. So now they all at least have the same number of decimals. So it's a little bit easier, and I always think about this as money. So if this was $2.10, $2.11, $2.01, and then this one's a little weird, it's $2.11 and then more than that, right? Because that one's going to keep going forever. Yeah.
There used to be a currency called pennies.
Yes, there was. 2.01, certainly that is my smallest, right? $2.01, I'm all set. Now the question is, out of these 3 that's left, who's smallest? Alexis?
2 and 10. 2.10.
Yes, $2.10. So that one's going to come next. In my list, it's just 2.1, so it doesn't really matter if you have the 0 there or not. So that one's taken care of. Now, out of these 2, 2.11 and 2.1 repeating, which one's smaller out of those 2? Alexis?
2.11.
Yes, that's $2.11. This is $2.11, but the ones keep going, so that's a little bit more than that. So the next one will be 2.11. And then last would be 2.1 repeating.
Okay. Wait, it's still recording.
I know. What if, let me make it even more interesting. Let me throw one more number in this mix. Where would this number go? 2.01 repeating. Where in this list would that number go? If I'm trying to go least to greatest. Cohen? It'd be where? Perfect. So if I snuck one more in there, 2.01 repeating. I don't want you to think that if it's a repeating decimal, it's automatically the biggest. It's not, right? Because that's $2.01 and then a little bit more.
Yeah, it's not bigger than 2.7.
Exactly. Oh, okay. You guys are all right. Let's try one more where you're ordering fractions. Let's make it as hard as I can. Let's make it, they're all fractions and they're all negative. Order these from least to greatest, if you would. Least to greatest. Oh, let's do -3/4, -1/2, and -1/3. Order those 3 for me, least to greatest, please. Hold it, well, write down your answers, everybody. You're so quick. I appreciate that you have some answers. but I want you to write them down first. Everybody has answers?
Yeah.
Devin, what's the smallest in this whole list?
Negative. Oh, smallest?
Yeah,
The one under least.
that?
Yes.
How do you not notice that?
It's close. The one closest to 0 would be the bigger one.
No.
Yeah,
Yeah.
you're right. So, no, you're right. That is the least in my whole list.
Yeah.
What's the next least? Go ahead, Joe.
1/2.
Yeah, the negative 1/2. They're already in order from least to greatest.
I knew that.
Because remember, in negative land, the bigger the number actually is, the smaller it really is in negative land. All right, guys. So I think you are ready to try some on your own.